Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson. So far, in our unit on integral calculus, we have learned about two types of integrals: definite integrals and indefinite integrals, or antiderivatives. We have also learned three techniques to calculate antiderivatives. Today, we will focus on definite integrals. Students, as you may remember, a definite integral calculates the area under a function over a set range. It divides the irregular shape under a function into rectangles, an infinite number of rectangles, in fact, and then it adds up their areas. A definite integral is therefore a sum. It results in a definite value, a real number, and has no constant of integration. Students, observe that a definite integral has limits, an upper limit and a lower limit. These limits set a definite integral apart from an indefinite integral. In mathematical notation, the lower limit a is written at the bottom of the integral sign. The upper limit b is written at the top. The region between these limits is called the domain of integration. Be aware that this region is often an area. However, it could be a volume or an even higher dimensional space, depending on the number of variables in the function to be integrated. The function to be integrated is called the integrand. Students, let us look at an integrand now. Consider the example: 3x squared plus 4x plus 1 dx between the limits of 1 and 5. To evaluate the integral, we first find the integral for the function and write it in square brackets. We add the upper and lower limits to the outside. We now have square bracket x to the power of 3 plus 2x squared plus x, where x is 1 to 5. Step 2 is to substitute the upper limit 5 into the integral and solve. So we have 5 to the power of 3 plus 2 times 5 squared plus 5. 5 to the power of 3 is 125. 2 times 5 squared is 50. And 5 is 5. Add them together and we have 180. Wonderful! Step 2 is done. Step 3 is to substitute the lower limit 1 into the integral and solve. That gives us 1 to the power of 3 plus 2 times 1 squared plus 1. Easy, right? 1 cubed is 1. 2 times 1 squared is 2. And 1 is 1. The sum is 4. Students, our last step is to subtract the integral of the lower limit from the integral of the upper limit. So, we subtract 4 from 180. The integral of 3x squared plus 4x plus 1 dx is 176. Students, let us practice the 4 steps of definite integration again. As an activity, evaluate 2x plus 3 times the square root of x dx between the limits 4 and 9.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. How did you do? Let us work through the problem together now. You can correct your work as we go. The first step is to find the integral and write it in square brackets. The integral of 2x plus 3 times the square root of x is x squared plus 2 times x to the power of 3 over 2. Remember to add the lower and upper limits. Next, we substitute in the upper limit. In this case, 9. So we have 9 to the power of 2 plus 2 times 9 to the power of 3 over 2. 9 squared is 81. And 2 times 9 to the power of 3 over 2 is 54. Our total is 135. All we have left to do now is subtract the integral of the lower limit 4. The integral of the lower limit 4 is 4 squared plus 2 times 4 to the power of 3 over 2. 4 squared is 16. And 2 times 4 to the power of 3 over 2 is also 16. So, the integral of the lower limit is 32. Subtract 32 from the integral of the upper limit, 135, and we have our answer, 103. The definite integral of 2x plus 3 times the square root of x dx between the limits 4 and 9 is 103. Well done. Students, please take a few moments to try one more activity. Evaluate 5 plus 6 divided by x to the power of 4 dx between the limits of 1.2 and 1.6. Begin when you are ready.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Great job, students! You now understand how to calculate definite integrals. Definite integrals are used a lot to calculate the area under a curve and the average value of a function. They are also used in physics to calculate displacement, velocity, acceleration, and work caused by a variable force. In this lesson, we reviewed the definition of a definite integral and learned how it is different from an indefinite integral. We will continue our discussion of definite integrals in our next lesson. Until then, thank you, teacher. Thank you, students.